All right, so I'm doing this in bed because I'm about to go to sleep. It's midnight in Sydney right now. I'm about to explain how I'm gonna explain what causes gravity right now. So what we know is that gravity is the weakest force, and this is the first thing I'm gonna start off with: is gravity is the weakest force, and just make sure you remember this part. So how is it the weakest force? Well, if we're standing on Earth and we're holding a magnet, this magnet is much smaller than the Earth is. This is Earth. The magnet is going to pull this piece of metal against the force of gravity. So it's a lot weaker than electromagnetism. It's weaker than the weak force. It's weaker than the strong force. It's not actually a force, as I'm about to show, but it is considered the weakest force. That's why I have force in quotation marks. So let's talk a little bit about refractive index. So what happens here is if we shine a laser pointer towards water, what's going to happen is, or whenever there's a change of refractive index from one medium to another, what happens is the path of the light is going to change. So there's going to be an angle of refraction. So what's happening here is the light's slowing down in the water, and the light wants to go from point, let's say this is point A to point B, and it's, for you mathematicians out there, if you want to do the math, it's going to take the least amount of time to get from point A to point B, depending on the speed it travels in air and the speed that it travels in water. So that's another thing to keep in mind. One more thing to keep in mind is that if a car is traveling in, let's say, mud, for example, and the mud is thicker towards the water, so you can see it's a lot thicker here than it is there. What's going to happen to the car is, as it's traveling this direction, these tires slow down more than these tires slow down, and the car is going to veer this way. So the same thing happens with gravity. When there's a particle near the Earth, its time is slowed down more than if it's away from the Earth. So as you can see, I've drawn little clocks. Over here, time flows faster than down here. So near a black hole, time slows down a lot. So what happens, just like in the car analogy, is if there's a particle and it's traveling this way, it's going to veer towards the Earth due to the slowing down of time. So this is what really allowed me to visualize the cause of gravity. This is a gradient refractive index. So let's say, and I'm going to give a shout out to Action Lab for this. I honestly don't really like his videos. They're very childish, but I need to give him a shout out because watching his video on this really opened up my mind to the cause of gravity. So the way he explained it was he put some sugar in some water, he put some sugar in a tank, a glass tank, like an aquarium, and he poured water over it so that there was more sugar dissolved on the bottom than there was on the top. And what happened when he shined his laser into it was the laser kind of curved this way. And that got me thinking about, that's how gravity works. So the laser light travels slower here than slower in the bottom than it does on the top, and that's why it curves, because the refractive and the gradient refractive index. Now, this is the part that's This is the part that, I mean, we know this to be true. We know this to be true. Electromagnetism causes gravity. So here's the Earth, and electromagnetism, the Coulomb force is a lot stronger near the Earth than it is away from the Earth. And what's happening is when a particle travels in this direction, it's being bombarded by all this electromagnetic force. It's picking up, it's absorbing and emitting photons more so towards the Earth than away from the Earth. So by absorbing and emitting photons, it's slowing down, and it slows down. It does this more towards the Earth, so it slows down more towards the Earth. So what's going to happen to the particle is it's going to go this way. And we know this to be true. We know that electromagnetism does cause gravity. I mean, we know this to be true. But they say that electromagnetism is not strong enough to cause all of gravity. They say that there has to be something else in play, which is kind of weird because the Coulomb force looks suspiciously a lot like the equations for the Coulomb force look suspiciously a lot like the equation for gravity. I mean, there's even an analog to gravity for magnetism. Here's the gravitomagnetism equations, and here are the Maxwell equations. So they're the same equations. And there's the Coulomb force equations and the gravity equations, and they both depend on the distance. They're both inversely proportional to the distance squared, radius squared, or distance from the centers of each massive object or each particle. And to me, that's suspicious because it's the same equation. And scientists do say that electromagnetism does cause some gravity, but not all gravity. And the equations are exactly the same. But what these scientists are forgetting is what I told you to remember in the beginning, that gravity is the weakest force. Well, not force. Gravity is emergent and emerges from electromagnetism. There doesn't need to be anything else involved because it's the weakest force. Electromagnetism is enough to cause gravity, and that is what causes gravity. Nothing else. And that's why gravity is such a weak force. And that's why the equations for magnetism are the same exact equations for gravity. It's just that gravity is a lot weaker. And that's why gravity increases by a factor of r squared as you get closer to the source of the gravity, as the two bodies get closer together, and they decrease by a factor of r squared as the two bodies go farther apart, because that's the same that happens with electromagnetism. So electromagnetism causes gravity. Scientists know this. They just don't know that electromagnetism causes gravity. Period. Nothing more, nothing less. That's all there is to it. Electromagnetism causes gravity. All right, I hope you guys enjoyed this. Like, share, comment, subscribe, I guess. I don't know. Do whatever. This is my gift to the world. It's been bugging me for a while. I've been meaning to put it out there. I don't know how. I just have a bachelor's degree in electrical engineering, and I've been studying physics during COVID, mainly particle physics. And when I discovered this January 2021, I was so excited. And it's actually been a burden for me, and I just need to let it out there. I need to let people know that electromagnetism causes gravity. And that's 10 minutes.